If you think a little bit about our previous lesson, it should be obvious that for a certain hypothesis test, whatever it might be, there should be a value starting from which you reject the null hypothesis and you accept the alternative hypothesis, obviously for a certain significance level. This value is called the critical value. So it is the one that for a certain significance level separates the critical or rejection region. Okay, what is this? This is the range of values for which the null hypothesis is rejected. From the acceptance region, what is this? This is the remaining region where the null hypothesis remains accepted. Okay, look that these terms accepted and rejected refer always to the null hypothesis. So if you have whatever test and you put it in terms of a probability distribution, then you will have something like this, okay? And you will have a region that will correspond to the rejection region, okay? Again, this is the region where the null hypothesis is rejected, okay? And the alternative hypothesis is accepted. And the acceptance regions, which is the remaining, the wider one, in which the null hypothesis is still accepted. Obviously, this will depend, the value of k, the critical value, will depend obviously on the significance level of the test. The bigger the significance level, the wider the rejection region. That's what I try to illustrate with these two colors. Here, you have two values of k, the k1 and the k2. This would be for a 10% significance level. This would be for a shorter significance level, which means that the critical value will be smaller for 5% than it is for 10%, okay? If this is for a case where the alternative hypothesis involves a probability that is smaller or equal to the null hypothesis. If you have something the other way around, okay, it's basically the same thing, but now the values are closer to that side, okay? It's convenient to say that these are one-tailed tests. We're going to have a lesson in which you'll have situations that involve tests that end up at both sides of this probability distribution. These are called appropriately two-tailed tests, but more on that later. So everything that you need to know in relation to this lesson is about one-tailed tests only. So how are we going to come about and figure out the values of the critical values for a particular test? Well, it involves calculating probabilities, using again the binomial distribution to calculate probabilities. Let me see if I can stop this where I want. Okay, to find the critical region of a test at a certain significance level, we must make calculations so that for a certain critical value k, either, I'm not going to just read, I'm just going to explain what this means, okay? So you are going to calculate several probabilities for the random variable x until you figure out a value of k for which the sum of those probabilities is smaller or equal to the significance level, and for which the next level of k, that is k plus 1, is already bigger than the significance level, okay? This is true when you are making a test of this first type, okay? If you are making a test of this type, where the values of k lie on the end side of the probability distribution, then the situation is going to be the other way around. It's going to be this over here, okay? So again, you are going to make a bunch of calculations of probability for x, and you start from the top down until you find the value of k for which the sum of these probabilities is going to be smaller or equal to the significance level of the test. And so that the next value of k as you go down, okay, so k minus 1 is already bigger than the significance level. Again, why smaller or equal and bigger? Because than the significance level. Because as we saw on the previous lesson, this is what decides if you are going to accept the null hypothesis or reject it. Okay? If the probability is smaller than the significance level, you reject the null hypothesis. If it is bigger, you accept it. Okay? That's the relevance of the value of k. You are figuring out the last value of k, the last value of the test that you are going to make, that separates one thing from the other. And again, if this happens, you will have the rejection region. The rejection region is the region over here where you will reject the null hypothesis, and everything else is going to remain as the acceptance region, where the null hypothesis is still going to be accepted.